Alrighty, we are in part 4 of chapter 4, Algebra 2 Review, and we're going to start with question 19. So it says, classify each graph as a function that's not one-to-one, a one-to-one function, or just not a function at all. So let's talk about what test we need to run for this. So first of all, if it's a function, it's going to pass the vertical line test. Just because it passes the vertical line test doesn't mean it's one-to-one. So how do you know if it's going to be one-to-one? It has to pass the vertical and horizontal test. This one passes neither, okay? So let's look at our first example. Oh, this is definitely going to be a no. And the reason why is as soon as I draw any of these vertical lines, you see how it hits in two different places? Can't do that. So for it to be a function, it can only hit the vertical line at one place. So if it's not going to pass the vertical line test, it's not going to be a function at all. Second one here, I think this one's going to be one-to-one. What happened to my question? Let me find it. Okay, I found it. So if I draw any vertical line, it looks like it's going to hit in the one place. So I'm good. So it's definitely going to be at least a function. So if it passes the vertical test, let's see if it passes the horizontal test. So if I go this direction, now it's a little bit sketchy here, but I'm going to tell you that this is going to go up and up and up and up and up. It's never going to be perfectly horizontal. So this passes both tests. So this is a 1-to-1 function. Now remember, if something is one-to-one, it means the function itself is a function, obviously. Also, the inverse is a function. All right, let's look at this one. Vertical line test, it looks like it's going to pass. This is actually a trigonometry function. This is going to be definitely a function, but if you change directions, it hits lots and lots and lots of places. So that's a no for the horizontal, but a yes for vertical. It's a function, but it is not 1-to-1. All right, and then this one over here, it looks like the domain is limited, but that's not going to really change anything. It's still going to pass that vertical line test. And it also passes that horizontal line test. So this one is also going to be 1-to-1, if it'll let me write it. All right, that's it for question 19. So question 20, just straight out the gate, tells you that they are going to be inverse functions. So inverse functions, they undo each other. The x's and the y's are swapped, which means your input, your output swap, and your domain and range swap. So they all kind of mean the same thing. In this question, though, it gives you coordinates. So if I know the point -3, 5 is on the graph of f of x, okay, and I know that g of x is the inverse, well, all I have to do is flip-flop the x and the y values. So that is the point that I'm looking for. So it has to be 0.5, -3. That's all you got to do is flip-flop the x and the y. Okay, question 21 is all about inverse theory. When you input -3, it is going to be the output of your inverse. So if you're inputting a -3, your output would be also -3. So the g and the f function cancel each other out because they are inverses of each other. It's very similar to if you have the square root of -3 and you square it, you wind up with -3. So that's not the problem, but that's kind of an example. So if you ever see any other input and you know g and f are inverses of each other, it does not matter what you put in the input. That will always be the output of the inverse. So final answer is going to be -3. Okay, so question 22 is a square root function. What we want to do is isolate everything in the radical, which means I need to get rid of this 4 and I need to get rid of the 12. If you have the choice, if you have the option, you're always going to add the opposite first, then you want to multiply and divide. I do have this option, so I'm going to subtract 12 first. Then I'm going to get rid of this 4. I'm going to divide both sides by 4. It does not affect the square root. Now at this point, I'm going to square both sides because it's isolated. So squaring a square root doesn't change anything. I'm still going to get x minus 7. Over here, 4 squared is 16. I'm not having any kind of warnings like go off in my head because I'm not squaring a variable. So I'm just going to simply get x by itself. So I wind up with x is equal to 23 as my final answer. Now, this does say to explain each step, so let's do that. All right, so in this first step, I went ahead and I subtracted 12 from each side. And then I divide 4 from each side. Or 2 each side. I guess that makes better sense. Okay, then now that this is isolated, I'm ready to square both sides. And after I do that, I finish it up by add 7 to both sides. And you don't have to check your answer. It's not going to be extraneous just because we didn't square a variable, but there's nothing wrong with checking your answer. So on question 23, this one is basically asking you about theory. One more time, I have mentioned multiple times that your x and your y swap, but I haven't really talked about the transformation. Back before when we were doing the first part of this lesson, you learned that when we graphed it, all of your functions and your function inverses are actually symmetrical over this line y equals x. So if you wound up with something that looks like x squared, the function inverse is going to look like this. So it's going to have this line of symmetry. Now I just freehand drew that. It's not great, but you can graph, always use Desmos, you can graph f of x and graph the inverse of it. And you can actually type in y equals x and see if you folded it on that line, see if they match up. And if they do, they're definitely going to be inverses of each other. So you can definitely use Desmos to visually check whether or not they're inverses. But specifically in this question, it says what's transformation? This is going to be a reflection. So a line of symmetry is like a reflection line. So we're going to reflect, actually, I'm going to reflect over the line y equals x. It's just checking to see if you know that occurs in your graphs. All right, so question number 24 is a really popular question. It provides you with a graph of f of x, and it wants you to graph the inverse of f of x. It does not give you any individual points. You're going to have to find them. The easiest thing for you to do is just kind of label minimum 5, especially if you have a curve. If it's a line, you only need 2, but it's a curve, so you need 5. And go ahead and just label all of these points on f of x. So this is f of x. So these are just the x and the y coordinates. Okay, I'm going to swap colors. I'm going to change to orange. And I'm going to start with the vertex here. And I'm going to swap this to be 3, 0. And I'm going to graph 3, 0. It's right here. And then I'm going to graph 2, 1. Sometimes it helps for you to like write it out instead of doing it in your head. And then this one's going to be negative 1, 2. Oh, looks like it's on the same point. It's just a coincidence. And I'm going to do this one would be 2, negative 1. Oh, there it is again. And then this one is going to swap to be negative 1, negative 2 here. Now you can very clearly see with these 5 points the curve. And you can also see that it is symmetrical on this diagonal y equals x. So you can just kind of visualize it. This is really the only way to do it, or the easiest way to do it. I wouldn't do anything else. So just let me know if you have any questions on anything, and that concludes your Chapter 4 review.